Greetings everyone. So today in chemistry we're going to be answering a question paper coming from 2019 paper 2 question B3, and it reads, the diagram below shows atoms of sodium and chlorine. So this is sodium and chlorine. And on our question where it says the diagram below shows atoms of sodium and chlorine, they're talking about these two diagrams that are over here. So our first question reads, state the type of bonding that exists in the compound formed when the two elements combine. So the two elements are talking about here is sodium and chlorine. Since sodium is a metal and chlorine is a non-metal, meaning it's ionic bonding. Why? Because ionic bonding, this is a bonding between metals and non-metals. So our answer is ionic bonding. Our second question reads, draw the structure of the compound formed when sodium and chlorine combine. So since there is not enough space, we can draw it over here. So we'll start with sodium. So sodium is Na. Okay. So we can do this. Yes, so here we'll count the number of electrons, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So why it's 11? Because if we go on our periodic table, the proton number of sodium is 11. So meaning it's going to have 11 shells. Electrons, sorry. Then chlorine. Okay. All right. That's that. Thank you. So, we've drawn the structures. Then what's going to be formed is that sodium is going to give away one electron to chlorine in order to make it stable. So we can use this very same diagram. So by getting this and just putting an arrow here to show that it's shared an electron with chlorine. So we can do this. So meaning it has shared one electron with chlorine, meaning chlorine has gained one electron and sodium has given out one electron. So to write it properly, we're going to do this. We'll write sodium here. So we're supposed to indicate here. Or if you want, we can just put the positive sign here. It's still going to show that it has shared one electron with chlorine. And if you want, it's up to you to put a 1 if you want. So we write our chlorine here. Here we can put a minus sign. So this minus sign here is going to symbolize that chlorine has gained an electron from sodium. And here, if we want, we can put an additional sign. So it's going to be like this. Then this is our last shell. Remember, sodium has given out one electron to chlorine. So in order for us to show it here, so we're going to put an X. The ones that are here to show that it has gained. And we put them in brackets. And we put -1. We're done. Then our third question, B2 reads that state the chemical formula for sodium and chlorine. Yeah, sorry, it says state the chemical formula for sodium chloride. So sodium has got a valency of 1 and chlorine has got a valency of 1. So for it to be called sodium chloride, it means that sodium and chlorine have been combined, which is sodium chloride, and all of the elements have got a valency of 1. So it's going to be NaCl. Question C. Explain in terms of bonding and the structure why sodium chloride has the following properties: a very high melting point. So remember, sodium chloride, for it to be combined together, meaning it's ionic bonding. So in short, they're just asking us about the properties of ionic bonding. So why does sodium chloride have a high melting, and why does it have a high melting point? It's because the ions have strong electrostatic forces of attraction. Because they have strong electrostatic forces of attraction. We're done. Then our last question reads, why does sodium chloride have a high electrical conductivity when it's in molten state? So the reason why it's got a high electrical conductivity is because the ions freely move in molten states. So you write the ions move freely in molten state.